Hello and welcome to Tomorrow's Tech by IDTechEx. I'm your host, Dr. Tess Skirm, and in this podcast series, I'll be interviewing an array of industry experts on emerging technology from IDTechEx. IDTechEx is a market intelligence company with a mission to provide clarity on emerging technology. In each episode, our analyst will be discussing all kinds of topics, everything from virtual and augmented reality hardware, autonomous vehicles and flying cars, sustainability and energy storage innovations, medtech and wearables, 3D printing, advanced materials, and so much more. In each interview, we're going to explore what the future outlook is for each of these technologies, as well as endeavouring to find that elusive insight into hype versus reality. The topic of today's episode is autonomous vehicles, sometimes referred to as driverless cars. Sci-fi movies have featured driverless cars for years, transporting superheroes around futuristic cities at high speed. Yet the development of autonomous vehicle technology for the real world is also continuing to advance. Regarding his most recent report on this technology, today's expert guest, Dr. James Jeffs, has said the following. After years of waiting, false starts and much hope, a new era has arrived for the automotive industry. The age of autonomous cars is beginning to dawn, and the next 20 years will be transformative for the transportation industry. Dr. Jeffs, welcome to Tomorrow's Tech.
Hi, Tess. Thank you for having me on this week. My name's Dr. James Jeffs. I've been with IDTechEx for 2.5 years now, and during that time, I've researched autonomous vehicles extensively. I've covered quite a wide range of vehicles, from consumer vehicles that we can go out and buy and drive on the roads to commercial vehicles like trucks and buses, the robo-taxis that have been testing in California and in China, and then all the enabling technologies as well. So I look at radar, LiDAR, cameras, semiconductor technology that's going to be backing up those different sensors. The whole remit really, from like raw semiconductor material all the way up to robotaxi markets.
Yeah, it's such a fantastic topic. It was one I wanted to cover in the podcast series so early because it's just something everybody can relate to. I think we've probably all had a kind of futuristic vision of the day that we might get into a completely driverless car. But that brings me on to where I wanted to start our discussion, really, because I've just quite freely used driverless car as a synonym for autonomous vehicle. But is that technically accurate? And if not, what actually is the definition of an autonomous vehicle?
Well, I guess the place to start would be talking about our definitions of autonomous vehicles and what we mean, and getting the nomenclature in place so that we can have this conversation. So about a decade ago, maybe a little bit more, the Society of Automotive Engineers came up with some definitions of what an autonomous vehicle is, and they put 6 levels together, 6 levels of autonomy, which is what we refer to when we're having this conversation in industry and when we're wanting to, talk about exactly what technology we're referring to. So it goes from level 0 all the way up to level 5. Level 0 is completely unautomated. It's like a go-kart. It's a car you might have had in the 1990s. It's got a steering wheel and pedals, but it's completely manual. Level 1 starts to introduce basic automated features. Things like cruise control would be considered a level 1 technology. And, I think most people now are going to be familiar with cruise control. It's fairly hard to buy a car these days that doesn't have cruise control fitted. So then we move up to level 2, and then we start to get more advanced assistance features, and level 2 is kind of where most of the automotive market is today. So if you go out and buy a new car, chances are it's going to have level 2 technologies, or it will have level 2 technologies as an optional extra. So under that banner would be things like adaptive cruise control and lane keep assist. And really, for a level 2 technology, it needs to be able to input in the steering, so it's using cameras to detect where the lanes are, and it can do sort of lane centering, and it can prompt you to stay in the lane if you look like you're drifting to one side or the other. And then adaptive cruise control helps to keep a set distance from the car ahead, so that's a longitudinal technology. It's interfering with the speed, and it's doing accelerating and braking for you. So yeah, the majority of the market today is level 2 and below. And then we're seeing at the moment the emergence of level 3. So currently there's only one car on the market really, or 2 that are level 3, and that's the Mercedes S-Class and Mercedes EQS. Mercedes S-Class has been a sort of a flagship technology car for so many years. And when it adopts a new technology, that kind of signifies to the market and the automotive industry of what cars in 20 years' time are going to have on them, like all across. So, adaptive cruise control, for example, came to the Mercedes S-Class in around 2001, and nowadays adaptive cruise control is almost ubiquitous across the market. So level three means that it's fully autonomous in certain situations, and this is where we start to use driverless terminologies.
Okay.
So yeah, in and the difficulty is it's sort of highly regulated, and it needs to be certified, because when you start entering driverless, you come into questions of, well, who's to blame if the car has a crash or if the car's speeding while it's operating driverlessly?
Yeah, I think those ethical questions have been around for a long time. I'm sure many of us at some point have come across the philosophical debate about what would a driverless car do given the trolley problem. If we just take a step back from that for a second, though, I think what struck me the most initially when I was reading through some of your research is that I realised I hadn't connected how, because of the levels of autonomy classifications that you mentioned, many people will already have been in an autonomous car, because a lot of the features are about, at level 2 and stuff anyway, lane keep assist, cruise control, and features like that. So is that correct, that a lot of the cars on the market today are technically in the autonomous family, just at a lower level than this driverless vision of a vehicle that we would connect with the term?
Yeah, exactly. So on the SE5 levels, 6 levels of autonomy, yeah, that covers passenger cars that we drive, and level two is really quite common now. So yeah, it's if you go out and buy a new car today, especially if you were to buy something sort of mildly premium like a Mercedes or a BMW or a Jaguar, chances are it's going to come with level two technology by default. I think my last three cars have been
Okay.
level two. That's dating back to cars that I bought in 2018.
Okay. So, I mean, we all know that there's a lot of pressure on technology providers in general to bring out new gadgets and new features. But I get the feeling that with this idea of making cars more autonomous, it's about more than that. So what is the driving factor behind all of these features coming into vehicles?
So I'd say there's two driving factors. One is convenience, and the other is safety. And I've heard arguments that they kind of build on top of each other. So safety provides convenience, and convenience can be safety. So when we talk about the convenience side of it, we're talking about so level three autonomous cars that we can go out and buy, like the Mercedes S-Class, being able to take us on long motorway trips without us needing to pay attention. So that convenience of not needing to drive those long, boring hours across motorways. And yeah, where it's being implemented at the moment with Germany and parts of the US certifying, you can see the application, you can see the kind of business argument for having a completely driverless car up and down the autobahns where you might be sat for 2 or 3 hours at a time, not doing particularly interested in driving. That's the convenience side, and that's sort of the consumer side. But when we talk about autonomous cars, we're also talking about robo taxis and completely driverless mobility services, which is going to be sort of Uber-like services within big cities. But obviously, you're not paying for the driver within the car, so the convenience is going to be an Uber-like service at a fraction of the cost. And then the safety side. So a lot of it, a lot of the excitement is this kind of driverless desire and wanting to be whisked up and down motorways without needing to pay attention to driving. But what it will enable long term is better automotive safety. And we see features like automatic emergency braking, blind spot detection, um, sort of lane change assistance features, which are more aimed at reducing and preventing road collisions and road accidents. And the industry as a whole has kind of said that it wants zero road fatalities by 2050,
Yeah.
which is an enormously difficult target.
Mm.
I think last time I checked, road fatalities accounted for something like 1.3 million deaths worldwide
Mm.
annually. Um, a huge number. It's in some places it's the leading cause of death among like younger people. Um, a really difficult and really difficult target. And yeah, long way to get there as well. 2050, there's a lot of time, but a lot of technology and a lot more progression within autonomous cars that we need to see, and a
Mm.
lot more technologies that are sort of in research at the moment. So to get there, we're going to need things like V2X communication, where the cars can talk to, well, infrastructure, mobile phones, everything, so that we can start doing things like it's called collaborative perception.
Okay.
So uh, each car has information coming from sensors on other cars, and together they can map the entire environment and like see round corners.
So that's a great segue into my next question, which was going to be, what is it then that needs to happen before autonomous cars can really hit the mainstream?
Yeah, so it's very much going to be a step by step and an incremental progression. Um, so we'll separate it into two parts again. We'll separate it into the consumer parts of
Hmm.
cars that we drive, and then the robo-taxi and the replacing Ubers and having driverless cities part. So cars that we drive, we've got Mercedes and now BMW trying to certify level 3 for use in Germany and the US. So there's a few progressions that need to happen. Firstly, uh, the kind of overarching governing body for roads in Europe and a few other places, the UNECE, has regulations on what autonomous cars can do and limitations. Currently, autonomous cars are limited to 130 kilometers per hour under those rules and limited to operating exclusively on motorways. That's really important because motorways are quite a comfortable environment for an autonomous car. Everyone's moving in the same direction. You're not allowed pedestrians, cyclists. There's no traffic lights. It's what we call a very limited ODD or operational design domain. So although the speed limit at the moment under UNECE is 130 kph, Germany has only implemented up to 60 kph at the moment.
Right. Okay.
So the first big step in terms of regulation is going to be going from 60 to 130. And then you've got that kind of motorway pilot completely covered. That's step one. Step two is more countries need to start implementing these rules. So I mentioned at the moment it's just Germany, Nevada, and California.
Hmm.
So in the US, we're likely to see a state by state rollout. I think Arizona and Texas will be next examples. They've been quite friendly to autonomous testing so far. In Europe, I think it'll be the UK and France because they've been quite proactive in this so far. And Japan's already made some steps, but they have limited actions. They had Honda trying to put level 3 on the road in 21. But Honda only put 100 cars out on the road. They made them lease. It was kind of a soft launch
Right.
of level 3. So yeah, we need changes in legislation to allow more wider operational design domains. We need more manufacturers to be certifying, and we need more countries to start certifying level 3. So those are kind of the first steps for how level 3 technologies are going to move towards widespread consumer market. And obviously there'll be trickle down as well. So at the minute it's only available on cars that are like $100,000 and above. So it take a while, maybe 15,
Yeah.
20 years to trickle down to all cars in the auto market. But that's kind of how we expect that process to go.
Okay.
So that's, yeah, how we're going to see level 3 become widespread over the next 20 years.
Yeah.
And then in terms of the other side, the robo taxis and the autonomous mobility in cities, at the moment, we've got several services worldwide of sort of commercial robo taxis. So you and I can turn up in Phoenix and in San Francisco and in a few cities in China and in Las Vegas and download apps for different companies that are running these services, and we can pay for a driverless car to come and pick us up and take us around the city.
Oh, amazing.
That is a reality today. The next steps for those are going to be, well, they're currently run under kind of like exemptions and almost a trial basis. It's sort of fully commercial, but the governing bodies are watching it closely, and recently Cruise has been asked to reduce the number of vehicles it's got in testing, things like that. So what we're going to see is those cities that are running those trials and commercial activity start to loosen their grip, reduce the red tape, and give the companies running these programs more free rein.
Okay, so that is your expectation, is so because that's something that often gets talked about, is that, oh yeah, these services are available, but only in these small places in Nevada, and it's
Yeah,
pilot schemes. But it is your expectation that they will expand, they will roll out, they will become more kind of competitive commercial services as opposed to just novelties for the area.
I think we're watching that process happen right now. So in 2021, the only example I knew of was Waymo operating in a suburb of Phoenix.
Right.
In 2022, Cruise came online in San Francisco, and a few cities came online in China. In 2023, Waymo came online in San Francisco. Waymo expanded to the whole of Phoenix. The whole of San Francisco opened up. Um, Motional started in Las Vegas. Waymo's talking about going to Austin and to Los Angeles, and it started testing there, and so is Cruise. So we're seeing like the number of cities that are allowing commercial activity now starting to grow year on year. So for the next few years until around 2030, I'm expecting to see between 2 and 5 cities per year get added to that list. And then at some point, I think we'll get really comfortable with autonomous vehicles, and they'll be sort of well known within San Francisco and within Los Angeles. And then we'll see an Uber-like rollout of commercial services. So we'll see lots of cities coming online each year,
Okay.
and a widespread. So I think that's the pathway to autonomous mobility as a service and widespread robo taxis. But I don't think that massive growth and that sort of hockey stick moment is going to come until the early 2030s. I think we've still got some years of going a few cities at a time and really proving the technology.
And that timeline, as you say, to it taking off, so to speak, am I right in understanding then that you really think that is about regulation as opposed to the need for better technologies to make the cars safer, or is it a combination of both?
A combination of both, yeah. Definitely the regulation. So in the US, it's being heavily pushed by the sort of pioneering companies,
Yeah.
and I feel like it's the states that are kind of almost buckling or giving in to their demands in some ways, and trying to keep up with the pace of what the companies want to do. Definitely, at some point, there's going to have to be sort of countrywide legislation in the US to allow this to be used everywhere. Um, Europe has a different mindset. I went to a conference last week where we were talking exclusively about sort of standards and regulations around autonomous vehicles and how to prove the safety, and what kind of process should companies be following to identify all possible edge cases and run simulations and prove that the car's going to be safe. And yeah, in Europe, I get the impression that it's prove the safety first via simulation and theory, and then start rolling the cars out.
Right.
In the
Okay.
US, it seems to be the other way around, that they're getting it
Interesting.
on the road and then kind of working out the regulations and how to do it as we go along.
Okay. That's really
Um,
interesting.
yeah.
Is there any and so coming from someone who's I've got some of a sensor technology background, and I'm an engineer, but I'm not an expert in this area. In terms of the sensor technology that these cars have to get packed with in order to be able to, for want of a better word, see without a driver, what are the mainstays, and are all companies going about it the same way?
Um, so the main thing is lots of sensors, and if we look at the leaders, Waymo and Cruise, they pretty much agree on how many sensors they need. Both of them have 40, and that's split between cameras, radar, and lidar. But you do see disagreement in what's the most important sensor.
Right.
So Cruise relies really heavily on radar. It's got about 20 radar, whereas Waymo has about 20 cameras.
Mm.
Um, but yeah, in terms of like the sensor technologies and what we need, it's definitely a lot, and it's a mix of making sure you've got 360-degree view of multiple distances, of really high resolution, so you've got a really good picturing and understanding of the environment around you. And to support that, you need high resolution cameras, um, radar has been improving in technology, and we're getting sort of higher resolution radars, and LiDAR is maturing as well. You need the computer to back that up, though, so you need lots of processing power to be able to get through all of the information from the different sensors, fuse it together, process what's in the environment. But the second factor is robustness. So
Mm.
we see sort of on Mercedes and the S-Class, it uses 8 cameras, 5 radar and 1 LiDAR to do a similar job to Waymo and Cruise, not quite as well, but on the Mercedes, if the radar fails, if the LiDAR fails, you can hand off to the driver. It's always going to have a driver behind the wheel. But for the autonomous robotaxis, anyone can use it. You don't need to have a driving license to get in the back seat, and there's going to be no one in the front seat to take over. So if you have 1 or 2 sensor failures, you've got to make sure that the car can carry on. So it's all about robustness as well with those, and being able to plan for what happens if 1, 2, 5 of my sensors fail. What can I do to carry on getting this person to where they need to go?
Yeah, this is kind of comparable with aerospace to a point where it's just more and more redundancy.
Yeah, interestingly, when we at this conference I went to last week, the aerospace got brought up so many times as a comparison, and when we
Yeah.
were talking about how to monitor driverless safety, people were saying we need an FAA-like body that can review crashes, but for cars, it's so difficult.
Yeah.
I mean, the difference is a plane crashes very rarely, but it's
Sure.
very serious. Cars crash incredibly often, but it's normally just a bump and some paint damage.
Yeah. I guess that brings us back around to what we were talking about at the beginning as well, about kind of the pub conversation about, well, what does an autonomous car do if it's given the trolley problem? So how do you go about building ethics into algorithms that are running behind the scenes with these sensor systems, but also the regulations? Is there agreement on that approach, or is it a bit of a wild west?
Um, so from what I've seen, there are standards that tell you how to design the functional safety of the vehicle. So there's kind of 2 aspects to the standards. There's the functional safety, which is what happens if part of the system fails. What happens if a sensor fails? What should the vehicle do? And that's a different
Yeah.
answer for passenger cars and commercial vehicles. But then there's what's called SOTIF, which is the safety of the intended functionality. And that's more when it's operating, like everything on the vehicle is working, it's operating correctly. How should it behave in different scenarios? And what the engineers have to do under SOTIF is go through what they call sort of hazard cascades, which is if this series of events happen, how should the car behave? And I think that's where the trolley problem would be answered, but I'm not sure if that's anything anyone's ever done, because
Yeah.
I mean, when I've spoken to people working on developing autonomous cars about the trolley problem, uh, the answer is more, well, 2 parts. One, the trolley problem has never happened.
Yeah.
Um, it's a great ethical
Yeah.
question about sort of how non-human
Mhm.
things should work. But in reality, they don't think it's such a bizarre and unusual edge case. It's not really something
Yeah.
they're planning for. When we talk about edge cases a lot in autonomy, and that's identifying the sort of most tricky and challenging things. But the edge cases we tend to think about are more like, what if you've got someone wearing fancy dress and they're dressed up as a cow? What does the car think it is? Does it think it's a cow, or does it think it's a human, and how should it behave? Or what if you've got a heavily modified car that I've seen a picture of a car that looks like a banana? What should the car do then?
Yeah.
Even things like you've got a car advertisement painted on the side of a bus. So what's the cameras going to see? Those are the kind of edge cases that we talk about more.
Yeah. Yeah. And I mean, it's the buzzword of the year, so I'm slightly reluctant to bring it up, but is how important is AI in all of that, and image recognition? Is it a crucial part of it, or is it just part of the solution for some players?
Oh, AI is so important
Right.
for autonomy. So AI is used throughout the sort of autonomous stack and autonomous development for different things. So we've got AI for identification. So the camera's picking up a human and being able to classify it as a human. That's an AI task. We've got AI for the most of the the sort of driving strategy, what we do with the accelerator pedal and steering wheel, how the car actually drives is as an AI functionality to, like learnt from human driving a lot of the time. And that's because, I mean, could you imagine trying to program a driver for every case and do it in a deterministic way, a way that's like completely mathematical and from the mind of engineers of, equations of how much steering lock to put on in different circumstances. It tends to be trained with the AI data and hours of video. And then even in that video, so you train the driving AI with, camera reel from and inputs from human drivers. Um, Sometimes you're using AI to create new edge case scenarios as well. So
Okay.
adaptation scenarios. But I think one of the most interesting things that we talked about last week at this conference was Tesla have said recently they want their fleet of cars to kind of develop the AI system. So you've got your fleet of Teslas out sending data back to base. The AI driver at base is learning, and then it pushes an update to all the cars, and you develop your autonomous driving that way. But how does that work for validation? Because you're changing the software on the car continuously. How
Very
do you
tricky.
revalidate the car
Yeah.
and homologate and say that we've tested and proven and it's all good? So yeah, there's um, so much AI throughout the chain and really big part of the talk at the moment, especially the learning.
That really plays in as well to all the discussions around how more and more data is going to start to drive unlocking the applications of AI in industries outside of just advanced chatbots and autonomy in vehicles being a really good example of this. If we come back again to just thinking about how this transformative tech is going to impact everyday people, if I asked you to make some predictive statements, do you predict then that in my lifetime I could expect to be a regular user of robo-taxis, and could it become like a regular part of my process when I go on holiday, kind of getting an autonomous vehicle to the airport?
So I'm not sure if that's what we're going to use driverless taxis for.
Okay.
Um, just because, I mean, would you consider getting an Uber from Cambridge to London?
I might if I was going to the airport.
You take an Uber to the airport.
Yeah.
Okay.
Yeah.
Um, so yeah, that's kind of what I thought was going to be a rare use case for Ubers and robotaxis. I see robotaxis, the vast majority of their driving being geofenced to big cities like
Right.
London, San
Okay.
Francisco,
Okay.
etc. Um, I guess if you're going from London to Heathrow, maybe that would count.
Sure. Yeah.
But
Okay.
going from Cambridge to like Stansted, which is sort of halfway between
Yeah.
Cambridge and London,
Okay.
maybe that would be a robotaxi
But
case.
okay, so but if a different example, then you think it's feasible that within a geofenced area, I'm using the UK because it's my perspective, but you think it's possible that I could find myself in a driverless cab taking me around from one place to another in Cambridge?
Almost definitely in
Okay,
our lifetime. Yeah, definitely.
okay.
Um,
Because I imagine there would be, I don't know, do you think that that's a narrative that's understood in the general public consciousness at the moment, or do you think that autonomous vehicles and driverless cars are still thought of as being, something from comic books and sci-fi?
um, I think people are definitely aware of autonomous vehicles. If anything, people have misconceptions of how available autonomous vehicles are. We've gone through a stage where people thought Teslas were driverless
Yes.
vehicles, and
Yeah.
just because of their branding,
Sure.
and Teslas have been limited to level two. They're
Right.
um, sophisticated ADAS cars. So yeah, I think there's like a general awareness. I don't think the public are aware of how deep autonomous cars could become as part of our day-to-day
Mm.
lifestyle and mobility solution in cities like London. But you know, um, 20 years ago, we didn't really have a concept of what Uber could be,
Yeah.
and now Uber is just ubiquitous.
Yeah.
And I think um, at some point, autonomy will become almost a default transportation mode in cities because like at the minute in London, we've got ULEZ, the ultra low emission zone. We've got congestion charges. Cambridge, which is a minor city in the UK, is talking about a congestion charge. Similar things in Birmingham. There's this movement towards removing internal combustion cars from city centres, definitely, but also just reducing traffic in city centres. And my opinion is that by sort of 2050, we'll be starting to see driver-free cities. So we'll see city centres, like the very centre of London, become autonomous only zones, and that'll be the safety side of things.
Yeah.
At first we've got the convenience of robo taxis, but I think you look at the performance progression of robo taxis, and their safety performance is pretty much doubling year on year. If you can extrapolate that, and we add in technologies like V2X, where you've got collaborative perception, you can see around corners, then it's hard to see how human drivers could ever keep up with that kind of safety. I think we'll be, certainly in
Yeah.
cities, we could be relegated to just, you're not allowed to drive here because you're not safe enough.
Yeah. Exciting. I think that's my main takeaway is that autonomous vehicles are already more pervasive than I thought they were in terms of these lower levels, and that actually, the dream of the fully driverless could well be coming sooner than many of us actually think. So the last thing I wanted to ask you about, Dr. Jeffs, was something that IDTechEx have a lot of discussion around, and it's the hype versus reality with new technology. And I do believe that hype can be a bit of a double-edged sword. It can be seen as a very negative word if a technology is overhyped or if it receives hype at the wrong point in its maturity. But it also can be a positive word if it's example of hype as a result of technology really hitting the mainstream or finding success or big breakthroughs coming out of laboratories, etc. So, thinking about those themes within autonomous vehicles, what's your take on the hype versus the reality?
Being guilty of, for many years, saying, "Oh, autonomy is going to be ready next year. We're going to have fully
Yeah.
driverless cars next year. It's going to be
Yeah.
next year." So we've definitely seen that overhyping of how mature this technology is, and that some people have been more guilty of that than others. In terms of the hype cycle, we're kind of seeing it with funding right now.
Mm.
So we saw funding grow sort of in the mid-teens up until 2018, and there was a really infamous collision with an Uber autonomous car back when Uber had their own autonomous testing division. And it hit a pedestrian, I think, in Arizona, and unfortunately the pedestrian died. Um, and then that shook the industry, and as you'd expect, the funding went down significantly in 2019, but it grew again in 2020 and 2021, and then 22 and 23 we've seen a real drop off in the funding, which is indicating to me that the hype is starting to disappear, and we're starting to get into the reality of
Yeah.
if this is going to work or not. Luckily, that's coincided with this sort of progression and emergence of commercial services,
Mm-hmm.
which hopefully there's enough overlap, there's enough funding left that it can
Yeah.
now get off the ground on its own steam.
Yeah.
Um, but now we're starting to see, as these commercial services come online, more incidents of autonomous cars having difficulties, having collisions, sort of being publicized in the press.
Yeah.
So yeah, I've done a lot of research on how often autonomous cars crash and
Yeah.
how often they crash compared to human drivers, and they're not as good. The numbers say they're not as good. They're not that far off though, and they're improving. And I personally think we'll see them overtake human drivers in terms of safety, possibly end of this year or sometime next year. We're really that close. But every time an autonomous car crashes, that's a big news story. They're supposed to be safer. They're supposed to be better. So when it happens, it's going to be publicized. The thing is, they have sometimes really unusual crashes,
Right.
and I think that's the interesting thing. And they're really good at some stuff that drivers are poor at, and then sometimes when it comes to like very unusual situations, it would be obvious for a driver what to do, but really difficult for an autonomous car. So
Yeah.
two that stick out in my mind were both crews in San Francisco. But one was a cruise vehicle went through some hazard tape, some police hazard tape of a crossing that was closed down. And the crossing was closed down because there'd been a storm and a tree or something had fallen, or maybe a like cable
Yeah.
telegraph pole had fallen into the crossing. And it crossed through the tape on its own and then collided with the tree or the telegraph pole. And obviously, like a human driver's,
Mm.
even a bad human driver should be stopping for the hazard tape.
Yeah.
The other one was when a cruise crashed into the back of a bus, and that should be something that it can deal with, right? There's like loads of buses in San Francisco. Why can't it deal with a bus? Well, there was a articulated bus operating in San Francisco, which was really unusual. It doesn't usually have articulated buses. I think it was like replacing a downed asset that was, I don't know, maybe in for repairs or something. And the front half of the bus pulled out, but the back half didn't because it's
Oh, I see.
articulated. So the crew saw the front half of the bus and
I thought it was
assumed it
gone.
was getting out the way and then went into the back of the bus.
Mm.
So it's just these really unusual situations that humans probably wouldn't have crashed in. But then humans crash a lot because they do
Yeah.
things like go through red lights, drive dangerously, they're on their
Of course,
phone,
there's
they
those things.
speed. And it's those kind of things that is going to help autonomous cars become safer.
Yeah. Oh, well, thank you so much for all of your insights into this. I know you've done a huge amount of research for IDTechEx on this topic and spoken to endless players in the space. So my final question to you is actually regarding kind of in relation to where your research has led you. What are you going to be working on next? Is it related to autonomous vehicles or the supply chain or something different within mobility? What's your next topic?
Automotive radar.
Okay.
And that one kind of, yeah, you do your autonomous car forecast, and that's also going to tell you how many automotive radar you're likely to
Sure.
sell for different levels. So yeah, interesting one again. Like radar is widely used in the automotive market.
Yeah.
Like people might be unaware that they've got a level 2 vehicle. People might be unaware that their car already has 1 to 3 radar.
Yeah.
I think both of my cars have 3 radar because they've both got
Okay.
blind spot detection and they've both
Right.
got forward-facing applications. Um, and then there's kind of massive growth opportunities there for people want to put 4 radars on each car. People are talking about replacing the ultrasonic parking sensors with radar. And front radars have this massive performance opportunity where you can build bigger radars with essentially more pixels, and you can create what they're calling 4D imaging radars. That's a really interesting topic.
Yeah. Oh, fantastic. So, I mean, a lot of opportunities in the automotive market, as everyone's aware, but I guess, yeah, the benefit you have is by having got total forecasts for the various car sectors, you can really drill down into the materials demand, as you say, for these parts of cars that most of us that drive around every day wouldn't even think about. So if you could leave us today with just a few sentences of insight of, if we remember nothing else, about the autonomous vehicle market going forward, what is it that we should know?
I guess if there's one thing people should take away from this and be aware of about the autonomous car market, is that autonomous cars are definitely coming, whether we like it or not, and for some people in some regions, they're already a reality.
Thank you so much for listening to Tomorrow's Tech, hosted by IDTechEx. IDTechEx offers independent market intelligence on emerging technologies. For more detailed information on the topic of today's episode, as well as many others, please go to idtechx.com, where there are dedicated research reports on all of the emerging technologies we cover, as well as articles and free-to-attend webinars.